Alright guys, now it's time to start 11.3 Applications of Logarithms to Modeling. You guys should enjoy this. It's a section of word problems. So we're just going to work a bunch of word problems today. So let's start with number 9. Go ahead and pause the video if you want to copy it down. In 2003, the number of sport utility vehicles sold in China was predicted to grow by 3% a year for the next 5 years. What was the doubling time? Okay, so this is a fairly simple idea. So since we're told we're growing by 30%, the idea is that the equation should be something like Q equals A times B to the T. Well, since we're growing by 30%, we know that our B value, our growth factor, is 1.30. And we want to know what was the doubling time. Okay, so if we're starting with A, then double A would be 2A. So we want to solve 2A equals A times 1.30 to the T. Okay, makes sense. If I start with A, double that amount would be 2A. So all I have to do is solve this. Now what you should notice, let me pull this up a little bit, is when I solve this, immediately the A's cancel. So I'm left with 2 equals 1.30 to the T. Okay, so what we need is logarithms. So we're going to pull out our handy dandy calculator and apply log to each side. So we're going to get log of 2 equals T times log 1.30. All I did was I used that that fifth property that we use a lot. When after you apply log here, you can pull that exponent off. So we get T equals log of 2 divided by log 1.30. Plug this in our calculator. And we get 2.6419. So the doubling time is 2.6419 years. Let's not forget the units there. Okay? And let's move on to the next one. The next one will be number 10. So again, if you want to pause it, go ahead. Number 10 says a substance decays at 4% per hour. Suppose we start with 100 grams of the substance. What is the half-life? All right, well again, we're told decays at 4% per hour, so we're going to have some quantity equals A times B to the T. Our B value is going to be 0.96 since we're decaying at 4% per hour. And we're also told A is 100 grams. So this gives us our equation Q equals 100 times 0.96 to the T. Well, we want to know the half-life. So if I'm starting with 100, how much will I have at the half-life? I will have half of 100, which is 50. So we want to solve 50 equals 100 times 0.96 to the T. So we divide by 100. So 1/2 equals 0.96 to the T, right? So then we apply logs again. So log of 1/2 equals T times log of 0.96. We divide. T equals log of 1/2 divided by log of 0.96. Take out our handy dandy calculator. And we get T equals 16.9797 hours in this case. Okay, remember here, since we're working with word problems, we typically solve exactly and then we get the decimal as a number. All right, so that one's simple enough. So now we're moving on to number 3. Number 18. Again, go ahead and pause the video if you want to copy it down. A population of prairie dogs grows exponentially. The colony begins with 35 dogs. 3 years later, there are 200 prairie dogs. Okay, so little a, give a formula for the population as a function of time. All right, well, we know we're growing exponentially, so we have a function p equals a times b to the t. I'm using p here because it's population instead of some generic quantity. So we know that, let's see, the colony begins with 35 dogs, so that tells me a is 35. And then it tells me when t equals 3, p is 200, because 3 years later there are 200 prairie dogs. So we're going to use this to find b. So we know 200 equals the a, which is 35, times b cubed. So we divide 200 by 35 equals b cubed. And then to find b, remember, since to undo a numeric exponent, I use another exponent. So I'm going to raise each side to the 1/3 power. We don't use logs here because the variable of interest is not an exponent. So we get b equals 200 divided by 35 raised to the 1/3, which is to 4 decimal places. Y'all know I like 4 decimal places. 1.7878. So our equation is p equals 35 times 1.7878 to the t. Sorry about that, guys. Okay, so then we have a part B here, and it says, when will the population reach 1,000 dogs? Well, here 1,000 is going to be our population value. So here we set 1,000 equals 35 times 1.7878 to the t. So now we have an exponential equation because the variable of interest is in the exponent. So guess what we will need to solve this? We will need logarithms. That's right. So we divide by 35, gives us 1,000 over 35 equals 1.7878 to the t. We apply logs. Log of 1,000 divided by 35 equals t times log of 1.7878. Okay, pull it up for you. And then we divide. So we end up with, let me see if I can get this right. Alright, so we're going to get t equals log of 1,000 divided by 35 all over log 1.7878. And this will give us 5.7702. .7702, and that would be years. So it takes 5.7702 years to reach 1,000 dogs. Okay? And one more. Number 22. Big 4, number 22. Oh, accidentally turned the light off. Alright, number 4, the population of Nevada, the fastest growing state, increased by 12.2% between April 2000 and July 2003. What was the yearly percent growth rate? So let's see. So how do we want to set this up? Well, let's see. Alright, so we increased by 12.2%. So we're given an R, but it's not a yearly growth rate. We're told R equals 0.122, and this is from April 2000 to July 2003. So that is 3 years and 4 months. Months. Okay, so what we have here is we will do things like we did before. So we're going to have the population equals the initial population times our growth factor, 1.122. Remember, add 1. And then if I want to make this years, right, 3 years, 4 months, this is 3.25 years. Right? So what we're going to do is we're going to have 3.25 times t. Okay? So then, actually, no, I lie. We're going to divide. It's going to be t divided by 3.25 because I'm taking something that's bigger and making it smaller. And this is like my delta x. We always divide by that. So we're going to get, make it nicer, p sub 0 equals 1.122 to the 1 over 3.25 to the t, which is going to be 1.122 raised to the 1 divided by 3.25 is going to be P0 times 1.0361 to the t. Okay, and remember it's this because we had something in April 2000. We had some population, we'll call it P0. Then in July 2003, we had some other population, I'll call it P1. So therefore, what the delta x is 3.25 years. And remember, we always divide by that. So that's my fault. I'm sorry about that. So finally, this is our equation. So then little b says, what is the doubling time? Well, if my initial is P0, then double that would be 2P0. So 2P0 equals P0 times 1.0361 to the t. The P0s immediately cancel. 2 equals 1.0361 to the t. Apply logs. Log of 2 equals t times log 1.0361. T equals log of 2 divided by log 1.0361. So t equals 19.5453 years. And that's it. All right, you guys show up for class ready to work tomorrow, and I will see you then.